Um, it's like 8 through 26, but like, how do you want the answer?
Okay. In 3-1?
Yeah, because I can just like graph it on my calculator. And
Oh.
say,
Okay,
this
guys.
is why.
Here's the shortcut for these. Yes? If you can solve, guys, if you can solve for y, and there's one output, then it's a function. So can I solve this for y? I can subtract 5x by there. That's already solved for y. If I try to solve this for y, what happens? How do I get y by itself? How do I kill the square? And if I take a square root, plus or minus, so how many outputs are there? 2. That's not a function then. If you can solve for y equals one function of x, it's a function of x. It's a function. Then there would be one output. So a very in your face example is like number, where'd you go? 23 or 24? Do you see how that's just for an input that has more than one output? But that's because they took a square root and they had to put a plus or minus. Okay. A quicker kind of way is as long as your y variable is to a first power, then it's going to be more than likely a function of x. So everything that's not a function of x is where the y is to a different power than 1. You see that? Maybe? Okay.
Yeah.
If it's squared, that's an issue. Yeah. Okay. I don't think they put any cubes in it. Oh, they did. This one's a little tricky because if I take a cube root, it's all good. Why do I not have to put a plus or minus if I put a cube root? What do you cube to get 8? Is there another thing I can cube to get 8? Or another real number and be careful? No. What do I cube to get negative? Negative. And that's the only thing, right? But what do I square to get 4? 2 or negative 2. That's when you get an issue, right? Okay. Okay. So I do need some kind of work. And the most like algebraic work you could do is solve for y. If you're able to do that, it's a function. If you're not, meaning you get like a plus or minus or something, it's not a function. It's not a function. Okay. And I can't remember. So the beautiful thing about early math books, because the later you get into math, the further you get into math, you start to get these books that have no examples. And I can't remember, I'm not going to look for it right now. Pretty sure they had examples. I can't remember. Okay. I'm too zoomed in to see. Anything else from homework? Did I get to your other question? No. I'm amazing. You wanted number 36? Okay. I'm so helpful. Oh, okay, beautiful. Okay. This problem's a little bit even, but you can do it now considering what we've talked about. This one is easy. I feel very safe saying that. If it's not easy for you, it doesn't mean you're silly or whatever. It just means it should be easy. Because what does this one want you to do? Just replace c with negative 3. Well, what does this one want you to do? What do I replace with 2? Not c, p of c. So a 2 would go here, and I have to solve that equation. Now, it's a little evil, because we only recently figured out how to solve this equation. Now, you could see 1 works, yes? But the other answer you can't necessarily see. There is another answer. Does anyone know how to solve it now? Good. What is it about the problem that tells you need to do that? One of your variables is to a higher power than 1. So real quick, if this wasn't squared, would I have to get it equal to 0? What would I do? What would you do? First step. Add the c's. See how you can get all your c's into one term. Can you do that with that? What's c squared plus c? Yeah. Beautiful answer. Cheers. So I need you to be with me on this. We normally would get all my variable shit together and then divide by the coefficient, and I'm done. That's how you normally solve linear equations, meaning equations where the variables are to the first power. Right? I cannot do that here, so we have to have another way around this. That's where we subtract the 2, get it equal to 0, factor, yes? Okay. So then you'll get the other answer. You'll get 1, but you'll also get the other answer. Now you could sit there and guess and test until you get it. Guess and check. But I highly recommend you don't do that. Okay. I love this. This is perfect, because some of these problems are a little bit trippy. So when nobody asks questions about some of these, I get concerned that everybody's kind of like, he won't notice I didn't do that one. I remember one semester some kid said, oh yeah, my friend told me that you sometimes miss if you, and I'm like, I'm gonna really check yours. What have you done to yourself? And I checked the hell out of his. I made sure if he was missing it. All right, anything else from homework stuff? 80? Oh yeah, okay. Y is x cubed, yes? Where is x cubed? No, y is x cubed. X goes from -10 to 10. To determine the range, tell me anything we know about range. Y-axis, it's all about the y's, yes? So if x goes from -10 to 10, how do you figure out what y goes from to? Do we know what x is doing? Given domain. So x is going from -10 to 10, yes?
Yeah.
So what's y doing? When x is -10, what's y? -10 cubed. Right? Do you see what I mean? So if I know what the inputs are doing, I put them in to see what the outputs are doing. And that'll tell me the range I can set the graphing calculator to. When you get the graph, give me a rough sketch of it real quick. Right? If you just do a rough sketch, I'll see if it looks about what it should do if you did put it in right. You with me? So there's another problem I think like this somewhere.
85.
85? There we go. Now it's got a cube root. So you do the same thing. If these are what your x's are doing, you plug them in to see what your y's are doing. It tells you what the range is. You make that your y max and y min. Is everybody with me? When you hit the window button on your calculator, you can set y min and y max. It tells you how far up and down you go. You have to do a little bit of work to figure out what to set that to. Yeah? Okay. Yes?
My last one is number 9.
Number which one? 90? Oh, that's the one. Yeah, I was about to say, is that the one about the ducks? All you got to do, the number on the inside is related to t, and what's t measure? Since 1990. So what would a 5 mean in place of t? We're in 1995, yes? That's when Windows had a major upgrade. Windows 95 came out. We were all like, holy shit, this is amazing. And of course, we're also playing Pong and shit. Oh my god, look at that. Huh? I'm sorry, what?
She said none of us existed.
Oh,
In 1995.
and who did? You did, okay. I definitely did. I had been roaming the earth for a long time. Yes, so, anyway. 5 inside the f means 1995. And what is the output? What does f of t measure? The number of ducks. I have no idea why you would pick f. You would pick like D or Q at least, right? For quack or whatever, but f doesn't make any sense. But it represents the number of ducks, so what does 30 mean?
30 ducks.
So make a complete sentence. There were
30 ducks.
30 ducks on the lake in, and okay, now you can do the same thing for part B, yes. So if you just take a minute and look, what does this variable represent? What is this? And then you can interpret that kind of statement. Easy. You'll be doing very similar things in calculus, but with kind of like calculus function stuff. You'll end up doing roughly the same thing, but you'll see when you get there. All right, anything else from homework stuff? Okay. So what I want to do is I would like to, yes, I want to finish this here, and then I've got a handout for you guys to work on, so I can shut the hell up tonight a bit.
Yeah, just here to work out.
I mean, if you got something wrong with your ears. So the instructions would say, obviously this sits, everybody has this from the other day, right, from yesterday?
Yeah.
Does anyone need this? Okay. So everybody's kind of getting the clue that they should take it out. Let me know if you don't have it for whatever reason. Even if you were here, you can get another one. I got one. I might have more somewhere. Okay. I want to solve this using completed squares. So let's do this together. How does that work? What do I have to do first? Does anyone remember what I've got? If I want to use completing the square.
Add 11.
Good. I need to make some room. I have to figure out what to add, so I need to get the 11 the hell out the way, right? So make some room. Is that the exact same thing? That's the exact same thing, Jeff. I just realized I put the exact same problem on the damn practice thing I did. That's gonna be a hard one, kids.
Put on the test too.
We'll find out, remember. So what are the 2 steps? What are the 2 steps to figure out what to add to both sides?
Half of the 6.
Okay, whatever's in the middle, you take half of it. And then I take that and I square it. And remember, this is just a shortcut from a pattern we noticed. When you multiply 2 binomials, we noticed how the middle term and the last term are created. So we use them to figure this stuff out backwards. So if I add 9 to both sides, how does this factor? I don't even have to think. Yeah, the first thing I did tells me what's going to go inside. But don't forget the square. That's the only thing that makes it true. So if I FOIL this, I will get this. Yes? So I really want you guys to do. There are numbers I could put here that would make this factorable. For example, very quickly, if I had used, so that's what I had to begin with, yes? If I did this, if I added 8, can I factor this? Yes, x minus 2, x minus 4. That's factorable, yes? That is not what I want though. I want something squared so then I can do what next? How do we kill the square? Squared. So that's great, that's beautiful, that's nice, but then it would not be equal to 0, so it wouldn't mean shit to me. I need something that is squared, and the only way to get the number that makes that happen is this way, instead of like just hoping I guess it. Is everybody with me? I mean, that's what that process does. It shows me the number I add to make it factor like something squared, because then it's relatively easy from here on out. Much easier than other shit we've done. I say that, hopefully. And what'd you guys just tell me? How do I kill the square? Which means I immediately put plus or minus. These die, bam. Can you simplify the square root of 20?
4 root 5.
Good. And square root of 4 is 2. Square root of 5 is, I don't know. So this will be, are you guys with me?
Yeah.
So get really used to simplifying radicals. It should be just as silly to leave an answer like 6/8. course you make that 3/4. Same thing here, square root of 20. That's silly. That's just like 6/, reduce that thing. Simplify it. Okay. And then, of course, last step I got to do is add 3 so I can get x by itself. Now, the sound effects you use at the end are up to you.
I think
If it's a test and you're surrounded by people, maybe make them quiet. Don't do the loud. Woohoo! We got it.
So it's fine if I do it tomorrow. Make sound effects.
So again, very, very, it's very quiet. Or you can sit way back there.
Okay.
Yeah.
The one facing outside.
That would be so funny.
The one
Just the kid in the back of the corner is like.
See, now I'm gonna do that. Just because you said it. Trust me, I will.
Oh man, I don't doubt it. All right. Does anyone see? What's one nice thing about number 2? This is very slightly nice.
They already moved
They already moved the 5, right? But what's the really terrible thing about number
left no space.
half
2?
of 27.
All right, there's no space. That sucks. So whoever made this, oh, it's me.
Half of 27.
No, not even that. No. Do you guys remember?
The first term isn't 1.
Yes. So complete a square is hardwired for the first number to be a 1. If the first number is not a 1, you have to divide by it. So if you divide by 9, and we leave a little space for ourselves, what happens?
Tree.
You just get that, right? So it's the same form as 1 was after we added 11, just the numbers are worse. One number is a fraction, and that always freaks people out. And the other number is a 3, and that's bad because what do I have to do to 3? Cut it in, which makes another freaking fraction. But, you know, too bad for us. So what are the steps? Take 3, cut it in half. And then what do I do to whatever I get? Square it. So now I can add 9/4 and add 9/4. Let me put this in a little force field. Okay. Now, I need you to understand, that looks gross, yes? We are, yes?
Can we go over how we get the part of
So are you cool with over here where I cut the -6 in half and then I squared what I got? Because that's the process, right? That's the process. And the process, don't give a shit what I'm working with, right? Over here, I'm working with a fraction. Process, don't care. It says, take the middle, cut them in half. Whatever you get, square it. Why does it work that way? Because that's how it works. We did it yesterday. I showed you some examples. We saw the pattern. We used the pattern. That's what a lot of math is. Why reinvent the wheel? We just see what happens every time, so let's just do that every damn time. I don't know if you guys are with me. So this is real easy to forget. But if you just remember, if I FOIL something out and it's the same thing, of course the middle term is going to be double this, because we're going to get it and then it adds to itself. And of course the last term is going to be square, so this is cutting it in half, undoing that doubling, and then squaring to see what's got to be there. That's all that process is. So how do I factor this?
X minus 3x.
X plus 3.
Or plus 3x.
Yeah. So the sign you use here is just whatever sign is here. It's actually whatever sign this is. And then on this side, what do I get? Oh shit. Bro. What's the denominator going to be?
36.
36?
You get 101.
Okay. So here's a really, let me see if you guys can handle this. Do you see on the bottom, they don't share any factors? So it is just this times this to get the LCD? this is one place where cross multiplication kind of works. Because what does this guy need? A 4. What does this guy need? A 9. So 4 times 5, 9 times 9. 20 plus 81 is 101 over 36. So you can use the idea of cross multiplication creatively, but we're not really cross multiplying. It's just a little bit of a shortcut. Or if you don't like that shit, give him a 4, give him a 9. You get a 101 over 36 no matter what you do. Still looks gross, yes? But we don't give a shit. How much did we actually, that's the most we had to do with fractions right there. That's the most we had to. I had to write fractions. Did I have to factor this? No, I just had to write the dumb fraction I got, yeah? That is the most I had to do. What do I do now?
Square root.
Square root. Again, we care that this is gross looking. And what do I put?
Hey, let's solve this one for.
That's what we're doing.
Oh.
What's the square root of 101? I don't know. What's the square root of 36? 6. Okay. And then what's the last step? How do you get x by itself? Subtract 3 halves, right? So I get x is negative 3 halves, plus or minus, square root of 101 over 36. There's no real good reason to combine those two. So I get the feeling, Kendall, that you thought there would be like a lot more. That's it.
Well,
That
no,
is
I
good.
wanted to find the square root of 101.
Oh, I see.
Yeah.
Square root of 100 is 10, so square root of 101 is like 10.07 or something. Yeah. Barely above 10.
You took out this, when it's 6, did you put the 6
Oh.
back into the?
It should be 6. I think I just thought this 3 was with this.
And that's like outside of the square root, right? The only thing I think.
The 6 is outside, because the square root of 36 is a nice full 6. Yeah. Okay. Let me stop for a minute. I need you to see, and I'm about to show you this amazing thing, the proof of the quadratic formula. You all know the quadratic formula. You all seen it. Negative b plus or minus blah, 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 blah. So even if you never wanted to see where it came from, I'm going to show you. Yay. So, what does the quadratic formula do? What's its purpose?
Defeats anything.
It does what?
Defeats anything.
Defeats anything. And it's not love, it's freaking quadratic formula. So, it solves this equation. Didn't we just figure out, no, real quick. This is nice, but you guys would probably think this is gross because there's no numbers at all. You're like, bring back the fractions, Jeff? But we're going to apply the process because the process will work the same way always. I'll take one of two answers. What the first thing I should do if I want to use completing the square in this? First thing I should, you guys look as excited as I thought you would. Subtract C, kick ass, make some room, yes?
Yeah.
I need you to understand, not a damn thing is going to change in the process we use. Is it going to look as nice? No. And to be really honest, it's going to be really nice because I ain't got to do shit. Can you combine C and B? No, there's going to be all the stuff I can't do anything with, which is nice if you think about it. So I'm going to subtract C. So I make some room here, yes? Then what do I have to do?
Take half of B.
No. What's wrong? Yes, divide by A, because what do I need out here? 1. So let me write this again. X squared plus B over AX equals negative C over A. Doesn't it already kind of feel like you can start to see the quadratic formula coming out? Okay. So you guys are like, I don't know. Yes?
Oh, why B over A, not BX over A?
You just said the same thing. So, real quick. What is 1/2 of 10? It's 1/2 times 10, yes?
Mm-hmm.
But isn't 1/2 times 10, 10 divided by 2? Aren't those the same thing? Aren't those the same thing?
Yeah.
Okay, so bx over a is the same thing as b over a times x. They're the same thing. Because what's under the x? Understood 1. So isn't that bx over a?
Yeah.
Okay. So if I have this equation for a line, what's the slope? Negative 1/3, because I can just shove the frickin' x out the way so I can see my slope, yes? Okay, good. So that's one. Good question though. Because how'd I go from there to there? I just made the x over 1 and put it over here, and x over 1 is x. Okay. Now, what do I do? You were about to say it earlier. Take the middle term and cut it in half, yes?
Yep.
So I want to take this and I want to cut it in half. Is that cool?
Yep.
If you have a fraction in the middle, don't divide by 2, multiply by 1/2. Then it works well with each other. And what is that? What? And then, what do I do with that? Square. What do you get? B square. 4a squared. Is that okay? Is that okay? I need you to understand. If you know the process, this is just writing a bunch of shit. The process is kind of like doing itself. We haven't had to do much. We divided by a. Woo! We put a 2 on the bottom. Yeah, we squared all this shit. So it looks terrible. We really haven't had to do anything. So what do I do now? What do I do with what we just did? What does it tell me? What do I do with this? I'll tell you what to do with that. Should be one.
You put it next to
Add it to both sides.
Add it to both sides. Nothing about the process changes. And then how do I factor this? That is an ungodly mess, yes? If I just gave you this on a test and it said factor that, you're allowed to come up and kick me in the shit. But why do I not give a shit here? Because how do I factor the damn thing? No thought required. B over 2? Yeah. Whatever the hell I did in the first step is how I factor the damn thing, yes? Equals. Now, fraction, fraction. How do I combine those fractions? No. So I need to multiply this by 4a and 4a, yes? To make 4a squared. So I get b squared minus 4ac over 4a squared. Is that cool? I just gave the guy what it was missing, then I could put them together, and that's really looking like the frickin' quadratic. Which step?
You lost me in the 1/2 times the b.
Okay, that's a while ago. Okay. You got me. I'm sorry. You're
You
fine.
wanna roll with it.
No. You stop me. Please stop me when I'm. How do I do completing the square? Whatever's in the middle, we cut it in half. That's all I did there, right? What's half of b over a? B over 2a. Is that all right? No, I mean, so if I had, for example, guys, if I had x squared plus 12x, yes?
Yeah.
First step would be half of 12. That's another way I can write it. We would put 12 divided by 2, but isn't half of 12 the same thing?
Yeah.
And half of 12 is 6. Well, what's in the middle? B over a. Half of b over a is 1 times b over 2 times a, 2a. Then whatever I get, the process says square. Then that is what I add to both sides, and that is how this factors. It looks like it should be hard, and I'm sure some of you guys are like, it is, dude, I don't know what you're talking about. But is anyone picking up on the fact that we really haven't done much? We really haven't. We just followed the process. What do I do now? Square root, which means I better put a, and that's why this plus minus is a quadratic form. So these kill each other. And then here, what's the square root of b squared minus 4ac? I don't have a freaking clue. But what's the square root of 4a squared? 2a. Then I just, and I've done, I subtract b over 2a, and since they have the same denominator, I said it right there, that's what, over 2a.
Oh my god.
Wow.
All right. Yeah,
You can't take b out of the square root
definitely not.
because it's part of the minus 40.
There it is. a square root cancels multiplication, it cancels raising to a power, right? It can't cancel part of a subtraction, yes? So can you do the square root of 17?
No.
Even though 17 is 8 plus 9, and you can do the square root of 9? That doesn't matter, because it's not a factor of 17. So b squared is not a factor, because it's subtracting, so it's not a factor of that expression. Yeah.
That's cool, I've never seen that. Like, I've never
Has
seen
anyone ever seen that before?
No.
Somebody just said, this is it, and you're like,
Yeah.
I'll put shit in there.
Yeah, exactly.
Tell me what A, B, and C are, just throw it in there. So,
Yeah.
you understand that it makes me a little sad. And I hope that you feel empowered to talk if I ever do something you're like, where the shit this guy get this shit from? Maybe don't put it like that. Hey, where the shit did you get that shit from? But stop me and say, because this is what you're here for, is to learn. And if they just give this shit to you, you have no connection to it. So we used a process that you guys have seen work. You guys have worked with it, you see how it worked. And then we used it, what did we just actually do? We just solved every quadratic equation in the universe, right now. Because if you give me what A, B, and C are, you get a different quadratic equation. So we just did every one of them right there. And that's why this thing is supposed to be the ultimate shortcut. To be honest, sometimes this is longer than completing the square. Most of the time, this is quicker. And that's why this thing is like the go-to. Okay, how do you guys do it? It's not the go, but it is the go-to. Okay. Oh, good. So let's do this. All right, let me shut the hell up finally, and let you guys work on this. So what I want you to do first is look it over yourself. Oh, thanks, Frank. I just forget. Oh, no, I can't. Just take this.
Your opinion, what's the goat equation now?
E to the I pi plus 1 equals 0.
I like that one too, actually. That's
You heard of that?
no.
Stop me if you've heard this.
Wait, say that again?
You ready? I'm going to write it down for you because it is actually the goat. Guys, E. Y'all know E? E. I. That's complex. That's the measurement. Pi we know. Yes?
Oh, yeah, pop.
Plus 1 equals 0. Math people geek the shit out. We have pi and E. Hello. Those are both numbers, weird ass numbers. They never stop, these non-repeating, non-terminating decimals that we gave symbols to. It has I in it. What the shit? It's got the multiplicative identity and it's got the additive identity. So we're like, holy shit. Now, I'm really sorry. We are nowhere near where I can show you why this equation is true.
I would like to see, I think
Huh?
I would like to see.
It would take a little while to explain what you need to know to do this. Unfortunately, in this version of pre-calc, we're not going to do some of what you need for this in the class. All right, I'm sorry. I totally went off on a tangent. But I just want you to know, I have an answer for if you ask me what the actual GOAT equation is.
I feel like I've seen that somewhere.
I have it.
I don't know what it means.
Of
but
course I
I've
have
seen
it on a shirt. But I gotta get a new one. That one's been beat up. Anyways, work on this. So look it over yourself. Try to find one that you feel comfortable doing, and I'm gonna have guys get into groups to kind of like help each other out. Okay.
Just one.
Huh?
Just one.
Well, do as much as you can. Look through it. Start with one that you're most comfortable with. Yeah.
What do you solve with?
Huh?
With that?
Oh, it's not like.
Isn't it like something to do with?
It's not like an equation or something, but it is an equation, but it's no variables in it. It's just a statement of truth. It's the same as saying 2 plus 1 is 3. It's just a fact. But there's a lot wrapped up into what the shit this is. Yeah. Well,
I'm gonna look it up.
alright. Right, I'll take one. You don't know, do you know what pi is in trigonometry?
Like
Radians?
radians, yeah.
Yeah. You know what angle it is?
Um,
So what's Yeah, it's 1/8. That's
Because
fine.
I know 360 is too
So,
high
do you
too.
remember when we multiplied and I did like, what if we do hacks, and that's where I came from? E to the I something means rotate by that angle in the complex plane. Like this is the real numbers, these are the complex numbers. So if I rotate by 1/8 degrees, don't I end up at -1? What's -1 plus 1? 0. Now, that's not a good enough explanation, because then your next question, what the shit is E to the I pi rotating with the shit? That makes no sense. But that's the short of it. That's why it works. I'm really sorry. I don't mean to derail everybody.
Yeah, that's interesting.
You asked me something like that, I'm gonna tell you.
Yeah, very interesting.
Yeah, it's neat.
What's E again?
That's like the exponential.
I was gonna say, is it exponential?
Yeah, it's 2.7128 blah blah blah. Maybe.
That's like compound interest stuff.
Yeah, that's the boring place it comes from. Not saying, but the standard place you hear where it comes from is letting compound interest go forever.
Yeah.
And then E pops out. There's a much more interesting thing where it comes from with infinite areas.
Infinite area.
Yeah. Well, anyway, sort of.
That's cool. Thank you, that was interesting.
You're gonna find on something interesting.
I know, I'm just saying, like.
No, I appreciate that. No. No, you're not supposed to be able to. See how this is not, you really can't simplify this in any meaningful way, so you should expect that the inverse is not going to simplify it. It looks good. Yeah, it's good. Oh, I'm still recording. It's exciting. So I was walking around, it looks like everybody pretty much got this one.
Yeah.
So for example, this is -9, -8, so my inverse goes -8, -9. -6, -2, so my inverse is -2, -6. 3, 1, so my inverse is 1, 3. And 8, 9, so my inverse is 9, 8. And then you get this neat little bug crawling around on your graph. Little bug. Got the antenna and everything. It's got an incredibly, it needs some food. There's its abdomen. Oh, there's, I can smooth this. This guy, so real quick, this is what's really kind of funny to me about inverses. How did I get those points I just plotted? How did you get your points you plotted? You took the original points and you switched the x and y, right? Exactly what I do here. This is why, if I switch the x and y,
That's right.
on one level this is kind of silly, because what do I want the inverse function to do? What should the inverse function of any function do? Cancel its original meaning it does the opposite of what the original did.
Yeah.
So that's why it would undo what the original did. If I do this, I start doing all the opposite shit in the opposite order. Yes? So on one level, you don't even have to understand you switch the x and y to get the inverse. This just makes sense. When I start to solve for y, I'm undoing everything. So the first thing I'm going to do, now here's the trick. Not a trick, but I'm trying to solve for y now, right? That's the term y is in. What is with this term on this side? Does that make sense? What's with this term on this side? Here's this term, yes? Here it is. Here's that term. What's with this term on this side? -3. Get rid of that shit. So find where the variable is you're trying to solve for. Find what term it's in. Get rid of all the other shit, right? So I'm going to add 3. Because now I can start freeing it up out of this term. Now that I've got this out of the way, how do I kill the cube? Cube root. And then I just kill the remaining operations. I would add 1.
What was that?
Huh?
That was terrible.
Okay. Divide by 3. So that makes it the quadratic. That was rude. So this is the inverse. So you would label this as F inverse.
Ugly.
That's
F.
hard.
How dare you?
In like a unique
Right.
way.
Right.
Ugly in a
When you
nice
try to
way.
spin that shit you just hurled at me. I have feelings.
I think that's worse than my wrong from yesterday.
Huh?
I think that's worse than my wrong from
Yeah.
yesterday.
Yeah. It almost made me feel sick. So, h of, now, so I started off with a nice one, yeah? We have to just keep reminding ourselves that at the foundation of it, all a function is substitution. So I see 2, plug it in, 2 squared is
4,
plus 3,
7.
7.
Check.
And then this one,
Yep.
I already did the work, so don't get too used to me doing this for you, but we know what h of 2 is, 7. And then if I plug a 7 into G, I get 21 minus 5 is 16. What's the square root of 16?
4.
4.
Plus or minus 4.
4 from 1.
I was gonna say, just watch the video for me. I know.
4 from 1D.
Stop. This guy is a little more involved because what am I shoving into H? This whole thing, right? So I first level is I replace the inside with what it is. Then this stuff gets thrown in here. I think everyone I looked at, I think did this right. The square and the square root cancel. Negative 5 plus 3. Negative 2. Chapeau. Okay.
Nice.
Thank you. Now, this is the one you just kind of get used to. I'm pretty sure I must have said this, but average rate of change. What's the other name for that? Slope. Slope is a change in y over the change in x. So it's how much my outputs change over a given input change. So do you see how my inputs changed by 3? Do you see that? You have to know that right now. No, but does everybody agree if my input starts at -1 and goes to 2, it changed by 3? Yes? Over that time, how much did my y's change? That would be the average rate of change. So my function, this function is, what was it? Oh, it's not 2 real. It's just parabola, but it's not a straight line, is it? But if I just take the beginning and end and connect it with a straight line, the slope is the average rate of change. How much did it change over the time? So all I need, I got x equal -1, I got x equals 2. I just have to complete the points, and then I can just do y2 minus y1, blah, 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 right? So when you see average rate of change, you think slope. How do you get the slope? Need 2 points. Get 2 points, get the slope. Okay, I always make it sound so easy. But it is. Okay. So if x is -1, what's y? Which function are we using? H of x. So if x is -1, h of -1 is y. What did you guys get? Okay. Sorry. It just looks like you guys are watching a movie or something. H of 2 is 2 squared plus 3. We already did that. That's amazing. So I want, sorry?
Sorry, never mind.
I could do it. So I want the difference in the y's divided by the difference in the x's. So I think everybody I looked at, I didn't look at everybody's, but everybody I looked at got 3 over 3, and that's 1. Yeah. Yes?
I was gonna say, wouldn't it be easier since we know in h of x 3 is the y-intercept? Why don't you just make your own point of 0, 3?
What do you mean? How does that relate to this?
What do you mean?
How does that relate to this problem?
Like, instead of having to do all that, because h of x is like from the previous problem, right?
Yes.
3 is the
3 is the y-intercept,
so
yes.
Isn't that already a point? You can make like it's 0, 3.
It is, but it has nothing to do with this. So real quick.
Well, I'm just saying that could be my second point. Like I don't have to do the 4.
But it's asking for a specific interval.
It's kind of like, if I want to know the average speed I was going on a trip and I only do it up to a certain point, that's not the average speed for the whole trip. I've got to go the whole trip. I've got to go from -1 to 2. If I go from -1 to 0, that's not going to be my average rate of change over the whole thing.
I got 1.
Well, how'd you do exactly?
I don't know.
Neat. Okay.
I just know I got the answer.
Let's see.
Well, since it's a linear equation,
What was right before? What'd you do exactly?
Well, I just did y2 minus y1,
Okay.
but with my 2 points were the -1, 2 that we were given, and then 0, 3.
Oh, this is not a point.
Oh, it's not?
Hell no.
Oh.
That is an interval
Oh.
on the x-axis. Yes. Okay. I see.
Alright.
So.
I don't know how I still got the right
No, you're
answer,
good.
though.
That's a little weird. We have to get used to this.
Yeah.
So, average rate of change. I want to know how much my output's changed over this interval. And if you just think of the x-axis as being time, very often it's time. So over the interval, that's an interval of time.
Oh.
From 1 hour before the space shuttle lifted off to 2 hours after. All right, t minus 1.
Yeah, I thought that was a point.
I got you. But it's got brackets, so it's
Yeah,
definitely not a
I
point.
was like, why is
And you're like, Jeff just probably hit the wrong button. Old man wasn't wearing his glasses. Okay. Oh man, I'm sorry guys. You get me at my worst here because it's a long day. Okay. Why does this not have an inverse? There's a lot of different ways to answer it. What's one way somebody answered that?
fails horizontal lines?
Yeah, if you graph it's a parabola that fails the horizontal line test. You could also say h of 2 is 7. What's h of -2? 7. So for one output comes from 2 inputs. That's exactly what 1-to-1 can't happen. 1-to-1 means every output has one input, every input has one output. That's why it's called 1-to-1. This one and this one go both ways. Oh, they got each other. All right, this is some max. Maybe? All right, so number 4, you only had to complete the square in part B. I'm really sorry to the person I started doing complete square roots. Okay. So what would you do for this one? Don't go straight to quadratic formula. That's crazy.
That's plus or minus, sir.
No.
Yeah, factor.
Oh, I see what you mean. Is that what you mean? Okay. In this case, they're opposite sides. But what are the numbers?
-10 and -30.
3. Yeah, the 10's positive, 3's negative. I like it. So then what are your answers?
X is -10.
Hmm?
6 positive 3 and no, positive 3 and -10.
Kick-ass. This one, you can refer to the notes earlier. Gotcha. Oh my god. And then this one is just loaded with shit. But you should have solved the equations. Your eyes should go to this part, yes? First thing you look for is to free everything up so everything can move around. This shit's stuck inside here, so I'm going to free it up. Negative x times x. Negative x times 2. Now, is there a higher power on any x besides 1? Is there a higher power than 1 on any x? When you see that, you want to get it equal to 0. That's the key. Unless all my x squared shit disappeared. So real quick, what is 4x squared minus x squared? 3x squared. If this 2x squared here was 3x squared, wouldn't the x squares cancel? Then you could just solve like you normally would. But we have squared shit that won't go away, so I've got to get everything on one side and factor. That's the way around not having like terms in x. That's the way we developed to get around that. So if I subtract 2x squared, and I subtract 7x, and we saw a problem exactly like this. And this is an easy one to make a mistake on. Everybody tries to make it more than it is. Stupid little GCF. Always try GCF first. Always. Just try GCF first. Because sometimes it's the only damn thing you can do, or sometimes it makes the next step easier. So what comes out? X. So then what are your answers? 0? 9. 9? Okay. Yes, that's right. So it's 9 and 9 are the answers. Gotcha. Shut up. don't totally shut up.
My
Just shut up.
favorite part of the class is his own.
Yeah, I don't need you guys here.
Just
All right.
absorbing.
How do you guys feel about that? So just to let you know, just to be sure everybody understands, number 4 is down on the quiz tomorrow. I just wanted to put 4 because that's the stuff we did yesterday. 1 through 3 is effectively like a little practice quiz. Yes? And then if you go see Maria, she's going to have other problems she can make that are like those. If you want more practice for tomorrow's quiz.
Yeah.
Okay. What else am I going to have for you tomorrow? Does anyone remember? We don't listen to you, Jeff. Huh?
The actual quiz.
Well, sure, the actual quiz, but beyond that. Because what's happening next week?
Take the quiz and we go. Oh my gosh.
Our first
Exam.
exam is happening on the 17th.
Oh Lord.
So I'm going to give you the practice test a little earlier than I normally would. I'm going to give it to you tomorrow. Most important thing is homework. Then practice test. So the most important thing is homework. Because that's practice enough, to be honest. But the practice just is a little extra study guide so you can see how I lay things out, all that kind of stuff.
How many units are being covered on this first test? Up to 4.2 or?
You guys tell me. You guys know?
Sorry, I should just look.
On that one.
Yeah, there's quite a few on this first test, to be honest. I went a little crazy.
Isn't it like 6? Like 5 things?
In 5 modules, yeah.
Yeah.
You see it? Test 1?
Okay, so we're covering module 3, so quadratics also.
Oh yeah.
Okay.
Craziness.
1, 4, 5, 2, and 3.
Yes.
That's fire.
So what I want to do the rest of the night, we're going to do this together, I think. Let me do this first. Anybody need to borrow a calculator? Come here.
Don't worry, I bought one, so it's coming.
Oh, cool.
How much you drop on?
You need my ID?
Yeah, let's do that. Keep me straight. Yeah, I know, it's like, one of you should have wore DC or something, but
I know, I saw that.
do we both
I
hate
didn't
DC?
even
Is
see
that what's
I'll be
happening?
honest. I'm just gonna.
I'm just a bigger Marvel guy
Okay.
than DC.
I'll go through it. Everybody else good? Okay. All right.
I think her Danny.
Bro, mine's
Yours have like
mine's a
iron.
bigger niche, bro.
Yours have like iron.
Mine's more niche, bro.
Oh, I see.
Is it
Yeah. You just have the entire, like,
Yeah, I have a
roster,
roster.
bro.
Yeah,
What's it say? Comic.
you have Iron Man and all. They made a movie on it. It's not niche.
Bro, this is niche, bro.
You know what movie on
I'm not talking about this is niche.
No,
All
that's
right.
not niche.
So crack out your graphing calculators.
Calculator. Bro, I know what
So I want to give us a function that we don't really look at visually too often.
What?
Translations, yes. Translation is a specific kind of transformation, so
When it's flipped.
let's just see what happens. Yeah. Reflections, translations are all kinds of transformations. Does anyone know what the square root function looks like if you graph it? Does anyone know it already?
Is it like,
Yeah, sorry.
is it half of us have?
You guys make me. You went.
It's
It looks like a parabola
Sideways and cut.
that fell down and lost its bottom half. Yeah, so it looks like this.
Yeah.
Yes. Square root of 0 is
0.
0. Square root of 1 is 1. Square root of 4 is 2. So it goes like that. So it is literally half of a parabola where the bottom half fell out. Why did the bottom half have to fall out? Because we defined square root to have an output that can only be positive. So it lost all its negative
Yes.
possibilities. Poor little guy.
Love that.
Okay,
That was good, I like that one.
thank you. So do you remember how to get that in your calculator?
Yes. Second x squared.
Second extra.
X squared.
Oh, I'm sorry.
Square root.
I'm talking about y equals.
Oh, my bad.
And then the square root button, like Damien said, is right above the x squared button. So square root x. Now everybody do this because your windows might be all trippy. Does anyone remember what? Now, to be honest, I can't remember if I told you. What button I push to get my window back to normal? Zoom, yeah, zoom 6. So then everybody should have this.
Yeah.
So that is a parabola that fell over lost its bottom half. Yes? So, if you have an older calculator, see, this one's kind of nice, and I've gotten so used to this. Look at all the colors I can. Oh, look at that. So let's just do this. Let's just do one thing at a time. Can you guys put that function in? Graph it and see what happens. Now, some of you guys remember transformations. Just sit on that for a bit.
Thank you.
What happened?
It was not working.
Was that one you borrowed from me?
Yeah.
Oh, that's so good. That's one I just charged. What happened? It just won't turn on?
If the battery is corrupted, it happened to mine.
Oh, damn it.
And it turns back off.
If you take out the battery, it'll be like this. It'll expand it.
Oh, no.
It's so fun.
Neat. Okay.
Don't, you didn't.
Oh, I'm so happy you told me that.
When you say that,
That was the first thing I was gonna do when I got home. Oh, it looks tasty. Wait, Maria said something. All right. So let me get to you. So square root of x plus 4.
Oh, let's graph this next.
Now, if you have an older one, does anyone have the square root button that's not growing? You know what I mean? See how the square root button grew to cover the whole thing? Does everybody have that?
Yeah.
Okay, good. Because the older ones had like a square root and they have that parenthesis open. So you didn't want to close a parenthesis until you were done with everything that had to be in the square root. But if everybody's got the square root button thing that grows, that's awesome. Now just hit graph. You'll see your original and the new one. What happened?
It moved that way.
What? Exactly how much? Yeah. So it went 1, 2, 3, 4 back. Now let's think about why that happens. What is the first thing that you do to an input in this? Add 4. So here's my silly example. You go into a bar, club, it's got a cover charge, it's got an entrance fee, right? And the entrance fee is $4. You with me? So you just want to go there and meet some friends. You're not going to get any drinks. You're going to hang out, and you ain't got no money. But you know there's a guy at the front door that'll give you $4, right? So then you can get in, because the first thing that happens when you get to the place is he gives you $4. He gives you the $4 that you need. So I could be. Oh, that's not the greatest example. No, I'll be right. Every input I put, the first thing I do is I give them 4 more. So if I put in there 0, this becomes square root of 4. Yes? So every input can be 4 less than it used to be, because the first thing I do is give it 4 more, right? So square root of x, what's the smallest I could input into square root of x? Smallest number I could put in there? 0. But now, what's the smallest number I can put in there? Negative 4. Because the first thing that I do is add 4 to it, which makes the square root not freak out. Now, this is one of the key things. Do you notice it went back 4? And students key way too much on this plus, and like, why the shit did it go back when it's plus? And it's because that is allowing me to go back. So what do you think is going to happen on number 2? This went left 4. Right 1, because now it's like I go to the club, $4 entrance fee. There's a guy out front, very particular mugger. He takes $1 from everybody, and everybody knows you just give them $1 because otherwise it's bad. See, how much money you gotta have just to get in? 5. So now every input has to be 1 bigger than it used to be. So of course it's gonna move right. Kick ass. So if I know the basic look of a function, I don't have to make a whole new table of values or shit. I just take the basic and I move it. So if I do this in here, let's see if I get what I said, minus 1, graph. And it's gonna move over there. Okay, I like it. It's very nice. Now, just a little side note. Do you see the red? Do you see how it looks like it catches up to the blue?
It doesn't.
It never will. But it looks like it does. Because it grows so slowly. Okay. So this will move right 1. Now, what do you guys think about this one? Do you guys see the difference? Where is the 2? Okay. This is not equal to this, yes?
No.
So I had a student that proposed our square root symbol should be this. It should have a back wall. So that you don't put extra stuff in, poor little dude, right? So whatever this is, whatever those outputs are, this is gonna make the outputs do what? Yeah, they're gonna increase by 2. So the whole picture, it's gonna happen to every output, so the whole picture is just gonna go up 2. So let's see if that happens. Spoilers, man. Shit.
Yeah.
Original. Up. Okay.
Oh,
Yeah, I know.
that's insane.
It's even better than the quadratic form.
I love math.
So what would this do?
Down one.
That's insane. Now, let me see if you guys, is everybody cool with that?
Yeah.
But do you see how if it's in with the letter, bless you, it does the opposite of what it looks like? What did this one do again?
Goes to the left.
Left 4, went back 4, even though it says plus 4, yes? If it's outside, it does exactly what it says. That's gonna go up 2. That's gonna go down 1. Are you guys all with me? Let me see if I can push my line. You ready? Can't I add this one over here?
Oh. Yeah.
If I wanted to, yes? So remember, what did this do again? That 4 is with the x.
Yep.
So it went back 4. Because it goes left 4. Because what's the x-axis? Left and right.
It's directly affected.
Now that I put that 1 with the y, it's going to do the opposite. All my outputs could be 1 less than they used to be. It goes down 1. Even if none of what I just said makes sense, I want students eventually have trouble with, why does that one I do the opposite and this one I do what it says? Because that one's not with its letter. This one is with its letter. If I put that with the letter, now it's going to go down 1. It does the opposite. If I put that with the letter, it's going to go up 2. It's going to do the opposite. Okay, but please don't look at it like that. This literally just takes that up 2, that down 1. What's that going to do?
That's gonna
Upside down.
All right, let's see. Jeff, what are you doing? Get in there. Okay, there's this. And then it finally makes a complete parabola. Hey! So that's what we call, you're not going to believe what we call that. We call that a reflection.
Wow.
So this causes a reflection around, what axis do we reflect around? X-axis. What is Y control? I'll show you in a minute. You ready? What is Y control? X controls left and right. Y controls.
Up and down.
Do you see how that negative, couldn't I put it on this side? Couldn't I divide both sides by -1? It would go with the Y. So if I can put it with the Y, it affects up and down. If it's with the X, it affects left and right. So what do you guys think is going to happen with this one?
Reflection over the y.
Yes, it's going to affect left and right. So it's going to shift from there to there. It's going to be a reflection left and right. Yes?
Yep.
So if I do it, did anyone have issues with this one? Just looking at it? Because it's the square root of -x?
No.
What can I put into this? What can I not put into this? Negative numbers, because that would be square root of a negative number and that would freak out. What can I not put into this one? Positive numbers, because if I put a positive number in, I need a negative number so the two negatives cancel. So that's why it's going to do this. There it is. Right. Bodacious. Yes, a very long wingspan bird. Okay. So just last thing, and then we'll wrap it up here. What does x squared look like if I graph x squared?
Over you.
Yes. Now, real quick, it goes through. I've got to make this a lot more eventually, but not quite yet. But I'm going to try to do a little bit. 1 goes to 1, yes. -1 goes to 1, yes. And 0 goes to 0. You with me? Those are what I call the anchor points. If I have an x squared, I know it's -1, 1, 0, 0, 1, 1. And then I can move those points around to figure out where the parabola ends up. So, can somebody tell me, what would this mean? What translation would this be?
Right 1.
Right 1,
And then down 5.
and then down 5. Now, I know I said here you no need to graph, but look at me graphing. Here I go, graphing again. So I'm going to move every point So that point, I'm gonna move it right 1. Give myself more stuff. Right 1, down 1, 2, 3, 4, 5. This point, right 1, down 5. This point, right 1, down 5. So then my parabola ends up there. Can somebody tell me, where was the vertex at first? 0, 0, right? Where's the vertex now?
1, -5.
1, -5. 1, -5. So where would the vertex of this parabola be? 7?
11.
11.
Oh, 7, 11.
To be really honest, I wouldn't even think about it. The minute I finished writing it, I'm like, okay.
I thought you did that on purpose.
I really, somewhere in the back of my brain I did, I'm sure about it. Okay.
Here with this one.
Does anyone even, yeah, we've done, I talked a little bit about
That's a
absolute
V.
value, right? This is a V, yeah. So this, where would it move? How would it move?
Left 4.
Left 4? Left 1. Do you guys see how you can identify the movement? I don't give a shit what function I give you. I can even give you a function that, can I? Yes. That you don't even know what it is. Yeah, let me do this. Yeah, here we go.
That's English.
Cosecant?
Nope.
Oh.
How will it move? Do you know what that? You don't know what that is. How will it move? Left 2, down 1. See, you don't even have to know what the function looks like to begin with, but you do know how the shit that thing is going to make it move. So when do these transformations work if you have a function? You can see. Even if you don't have a function, does anyone know what this was? I'm pretty sure we talked about this somewhere. Circle. So what would this do? Move it how? Right 1. No. Is it in with the y? It's in with the x, so it's the opposite. Right 1. Down 2. So the circle is normally centered at 0, 0, and now it's going to be centered at 1, -2. That's a really cool, just applicable every damn where idea. Transformations. You can disagree if you want to. I'm sorry. Okay. All right, that's enough. That's enough. So we'll leave the rest of the time for if you have questions. If you don't have questions, as always, you can just head out if you like. But let me know. Does anyone have any questions on what we did tonight or stuff left over from homework?
Are we doing the other half of this?
Yes. Tomorrow we'll finish this. So on the other side,
Questions about the quiz?
we have to apply. Well, now you kind of see. You can already see how to get the vertex, right? So this is just the next step of what we just did. Quiz tomorrow is going to be like the first thing, but after a few minutes for questions. Yeah.
Here you go, Jeff.
Oh yeah. Please give me.
It's about to die.
Oh no. Really?
Yeah.
What the shit? Oh, it is.
Should I flash my ID on camera? Have my identity be stolen?
Is this still going? Yeah.